Researchers are interested in the proportion, estimating the proportion. That's a key word here, who received the COVID vaccine. And then this question is, how large a sample do we want to collect? So our goal here is to actually compute the sample size. So we're trying to get in. And we want to estimate the proportion at the 95% confidence level within this margin of error. And so this is just a formula from the notes, the formula for computing the sample size to get a desired margin of error for proportions. I'm going to write it down. Here's the formula. It's z star over m squared times p star 1 minus p star. Remember, if you're working out a problem and you actually have a sample proportion, you would use that here. Otherwise, you just use 0.5 as your initial guess. So this is just going to become this times this is just going to be 0.5 squared. So the point is you just plug everything in. And so you're going to get n is 1.96. That's z star. Oops, I wrote that the whole thing squared. It should be 1.96 divided by the margin of error that we want, which is 0.015. So divide first, then square, and then times 0.5 squared. And when you work this out, you should get about 4,268.44. So we should say, so use sample size n equals 4,269. Round up to the nearest whole person. All right, we've got a poll saying that 72% of teens say they seldom or never argue with friends. Yanni, a particular student, wonders if this holds true in her school. So she surveys a random sample of students. And so she's wondering, do the results hold true? Are they the same? Are they different? There's not a direction here. So let's go ahead and label a few things. Let's let P equal the proportion of students in Yanni's high school who never or seldom argue. So we're looking at her specific high school. That's the unknown. That's what we want to study. And so in this case, we can immediately go ahead and compute P hat as well. She did a sample of 150 students. 96 of those were, quote, successes. So we go 196 divided by 150, and we get 0.64. So that's our P hat. So now we can come back and we can write down the null and the alternative hypothesis. These are claims about the population proportion that we're studying. We're studying the proportion of students in Yanni's high school. So if nothing is going on, her proportion is the same as the rest of the country. That means P is 0.72. Otherwise, it's different. So P is not equal to 0.72. So those are the two hypotheses. So that's kind of step one, state hypotheses. So step two, we want to compute the statistic. Let's go ahead and label these. Step two, we're going to compute the statistic, and we're going to get Z is, well, in general, it's P hat minus P naught divided by the square root of P naught times 1 minus P naught all over N. So you're going to plug everything in here, and you're going to get Z is 0.64. P naught is just the null hypothesis value. So 0.64 minus 0.72. I want to divide by the square root of 0.72 times 0.28. How did I get 0.28? It's 1 minus whatever this is. It's this P naught times 1 minus P naught. So I just plug that in, and then I'm dividing by 150. I'll leave the details to you, but you should get negative 2.18 for the statistic. So now for step 3, we're going to compute the p-value. We want to actually take double the probability that Z is greater than or equal to the absolute value of negative 2.18. When you plug it in the app, you can just go ahead and take the absolute value and just type in positive 2.18. Doesn't matter. But the point is, when you do this, you're going to get 0.029. So then step 4, we're going to draw conclusions. So we could say that the data is, or let's say provides, the data provides we'll say good evidence to reject the null hypothesis, i.e., evidence that there is a different, let's just say the proportion of bullying, or no, I'm sorry, not bullying, I'm mixing problems. Proportion of arguing, excuse me, the proportion of arguing at Yanni's high school differs from 0.72. That was a little bit of I didn't write it exactly the same as we did at the beginning, but it works. All right, so let's break here and we'll jump in the next page whenever you're ready.